Download this code from codegive.com, link in the description below. Configuring secure transport between Riverbed steelheads, a comprehensive tutorial. This tutorial provides a detailed guide on configuring secure transport, SSL/TLS, between Riverbed steelheads for secure data optimization. Secure transport is crucial for protecting data in transit, especially when dealing with sensitive information or when deploying steelheads across untrusted networks, example the Internet. Understanding the importance of secure transport. By default, steelheads communicate using a proprietary protocol optimized for WAN acceleration. However, without encryption, this communication is vulnerable to eavesdropping and manipulation. Secure transport addresses these vulnerabilities by *encryption protecting data confidentiality using SSL/TLS encryption. *authentication verifying the identity of the steelheads participating in the communication, preventing man-in-the-middle attacks. *integrity ensuring data hasn't been tampered with during transit. Prerequisites Riverbed steelhead appliances you'll need 2 or more steelheads to configure secure transport between them. Ensure they are running a compatible version of RIOS, Riverbed's operating system. Consult the Riverbed documentation for supported versions. This tutorial assumes RIOS 9.x or later. *root access you'll need root access or an account with administrative privileges on the steelheads to perform the configuration. *basic networking knowledge familiarity with network addressing, routing, and DNS is helpful. *SSL/TLS knowledge a basic understanding of SSL/TLS certificates, certificate authorities, CA, and key exchange mechanisms is beneficial. Steps involved in configuring secure transport *. 1. Generate or obtain SSL/TLS certificates *. This is the foundation of secure transport. You can *. Use self-signed certificates, for testing only, easy to generate but not trusted by default. Suitable for lab environments. *Use certificates from a public certificate authority, CA recommended for production environments. Trusted by most browsers and systems. *Use certificates from a private CA *. A good option for internal networks where you control the certificate issuance. To install the certificates on the steelheads *. You'll need to import the certificate and private key onto each steelhead that will participate in secure transport. 3. Configure secure transport settings on the steelheads *. This involves enabling secure transport and specifying the certificate to use. You can also configure settings like the TLS protocol version. 4. Configure secure peer authentication, optional but highly recommended. This ensures that each steelhead verifies the identity of its peer using certificates. 5. Verify the configuration *. Test the secure transport setup to ensure it's working correctly. 6. Monitor and maintain *. Regularly monitor the performance and security of the secure transport setup. Keep certificates up to date. Detailed instructions with code examples *. Step 1. Generating SSL/TLS certificates *. Using self-signed certificates, for testing only. Use OpenSSL, available on most Linux distributions, or installable on Windows/Mac OS, to generate a self-signed certificate. This will create 2 files. *steelhead.key, the private key, keep this secure. *steelhead.crt, the certificate file. B. Using certificates from a public or private CA ***. 1. Generate a private key ** same as above. 2. Create a certificate signing request, CSR same as above. 3. Submit the CSR to your CA *. Follow the instructions provided by your chosen CA, public or private. They will use the CSR to issue a certificate signed by their root certificate. The CA will provide you with a certificate file, usually .crt or .pem. 4. Download the CA certificate chain *. If using a private CA or an intermediate CA for a public CA, you'll need to download the CA certificate chain. This chain includes the root CA certificate and any intermediate CA certificates used to sign your steelhead certificate. The CA will typically provide this. Step 2. Installing the certificates on the steelheads *. You can upload the certificate and private key files to the steelhead using the web UI, usually the easiest, or the CLI. A. Using the web UI ***. 1. Log into the steelhead's web UI. 2. Navigate to configure optimization secure transport certificates. 3. Click import certificate. 4. Select the certificate type, either self-signed, CA certificate, or certificate/key pair. 5. If importing a certificate/key pair. ** Upload the steelhead.crt file as the certificate. ** Upload the steelhead.key file as the private key. Make sure the key format is compatible, usually PEM. 6. If importing a CA certificate. ** Upload the CA certificate chain as the certificate. This might be a single file containing the root and intermediate certificates, or you might need to upload them separately. 7. Provide a certificate name, example Steelhead 1 Cert. This name will be used to reference the certificate in other configurations. 8. Click Import. B. Using the CLI ***. Connect to the steelhead via SSH. Repeat this process on all steelheads that will participate in secure transport. Make sure to use different certificate names for each steelhead. Step 3. Configuring secure transport settings on the steelheads ***. A. Using the web UI ***. 1. Navigate to configure optimization secure transport general. 2. Enable the secure transport checkbox. 3. Select the optimization certificate that you uploaded for the steelhead, example Steelhead 1 Cert. This is the certificate that the steelhead will use to identify itself. 4. Optional, configure other settings. *SSL/TLS protocols * specify the acceptable SSL/TLS protocol versions, example TLS v1.2, TLS v1.3. Disabling older, insecure protocols like SSL v3 and TLS v1.0 is highly recommended. *Cipher suites * specify the cipher suites that the steelhead will use for encryption. Choose strong cipher suites that support forward secrecy, example EC RSAAES 256 GCM SHA 384. Prioritize stronger suites. 5. Click Apply. B. Using the CLI ***. Repeat this on each steelhead, adjusting the certificate name and other settings as needed. Step 4. Configuring secure peer authentication, highly recommended. This step ensures that each steelhead validates the certificate presented by its peer. This prevents man-in-the-middle attacks. A. Using the web UI ***. 1. Navigate to configure optimization secure transport peer authentication. 2. Click Add Peer. 3. Enter the peer address, the IP address or host name of the remote steelhead. 4. Enter the certificate name, the name of the CA certificate, example CA certificate, that sign the remote steelhead certificate. This is crucial. You're telling this steelhead to trust certificates signed by the CA for this specific peer. If you used self-signed certificates, this will be the self-signed certificate of the remote steelhead. 5. Click Add. Repeat this process on each steelhead, adding an entry for each of its peers. B. Using the CLI ****. Important notes on peer authentication ****. If using self-signed certificates ***, you must copy the certificate of the remote steelhead, example steelhead2.crt, to the local steelhead and import it as a CA certificate. Then, in the secure transport peer command, specify the name you gave to the remote steelhead certificate. If using a public CA ***, you should not need to configure peer authentication because the CA is already trusted. However, it doesn't hurt to add an entry specifying the root CA certificate for the peer. If using a private CA ***, you need to install the CA certificate on each steelhead and reference that CA certificate in the peer configuration. Step 5. Verify the configuration ***. After configuring secure transport, verify that it is working correctly. 1. Check the steelhead logs ***. Look for entries related to secure transport and optimization. Errors or warnings in the logs can indicate problems with the configuration. Use the web UI, report system event logs. Use the CLI, show events or show events detail. Look for messages indicating successful SSL/TLS handshakes and secure connections. 2. Run show active connections on both steelheads ***. This command displays the active connections being optimized by the steelheads. Look for connections that are using secure transport, example connections with secure listed in the output. Examine the output for connections being optimized and look for entries related to secure transport. You should see connections that are being secured and the cipher suites that are being used. 3. Simulate traffic ***. Generate some traffic between the sites where the steelheads are deployed. Monitor the optimized traffic using the show active connections command or other monitoring tools. 4. Use dump or Wireshark. For troubleshooting, if you encounter problems, use dump or Wireshark to capture network traffic between the steelheads. Examine the SSL/TLS handshake to identify any issues with certificate validation, protocol negotiation, or cipher suite selection. You can run dump on the steelhead directly from the CLI. Download the capture.gap file and open it with Wireshark for detailed analysis. Step 6. Monitor and maintain ***. Certificate expiration ***. Monitor the expiration dates of your SSL/TLS certificates. Renew certificates before they expire to avoid service disruptions. Consider using a certificate management system to automate certificate renewal. Security updates Keep your steelhead software up to date with the latest security patches. Protocol and cipher suite updates Regularly review and update your SSL/TLS protocols and cipher suites to ensure you are using the strongest and most secure options. Disable any outdated or vulnerable protocols and cipher suites. Log monitoring Regularly review the steelhead logs for any security-related events or errors. Example configuration summary Steelhead 1, 192.168.1.10. Certificate, Steelhead 1 Cert, signed by CA Certificate. Peer authentication, Secure Transport Peer 192.168.1.20 Certificate Authority CA Certificate. SSL/TLS Protocols, TLSV 1.2 TLSV 1.3. Cipher Suites, EC RSAAES 256 GCM SHA 384 EC RSAAES 128 GCM SHA 256. Steelhead 2, 192.168.1.20. Certificate, Steelhead 2 Cert, signed by CA Certificate. Peer authentication, Secure Transport Peer 192.168.1.10 Certificate Authority CA Certificate. Asterisk SSL/TLS Protocols, TLS v1.2 TLS v1.3. Asterisk Cipher Suites, EC RSAAES 256 GCM SHA 384 EC RSAAES 128 GCM SHA 256. Important considerations Asterisk performance Secure transport can introduce some performance overhead due to the encryption and decryption processes. Consider the impact on your network bandwidth and latency when enabling secure transport. Riverbed steelheads are designed to minimize this overhead, but it's still important to monitor performance. Firewall rules ensure that your firewalls allow communication between the steelheads on the necessary ports, usually port 7800 for secure transport. Compatibility make sure that the steelhead versions and SSL/TLS configurations are compatible with each other and with any other network devices involved in the communication path. Certificate revocation implement a certificate revocation mechanism, example using certificate revocation lists or online certificate status protocol, to invalidate compromised certificates quickly. Testing thoroughly test your secure transport configuration in a non-production environment before deploying it to production. By following these steps, you can effectively configure secure transport between Riverbed steelheads, ensuring the confidentiality, integrity, and authenticity of your data as it traverses the WAN. Remember to tailor the configuration to your specific network environment and security requirements. Always consult the official Riverbed documentation for the most up-to-date information and best practices. Regularly review and update your security configurations to stay ahead of potential threats.